Okay, so basically here we've got the turbo components of the car. So Eric, the owner of the Yaris, has gone for a G25 550 with an 072 housing to hopefully keep the spool to a good degree. We've got a cast manifold here. We've got some good Turbosmart components to run alongside, and we've got a Funk Motorsport unit there for heat control that sits over the top of the exhaust housing. So Joel, give me some idea of what we're looking at with the exhaust manifold here. It's obviously a cast unit. What's the benefits, the pros and cons with this unit?
So obviously with a manifold like this, obviously we have got an external wastegate, so that's obviously always quite a nice feature to have. You know, we can, you know, if we're tuning the car, if we want to make slight alterations to the gates and stuff like that, within reason, you know, sort of fairly easy to, you know, remove the gate and swap springs over if we're trying to achieve a different boost pressure. Obviously with the tubular, compared to, you know, some of the OEM type manifolds, we can find that it does help increase the velocity of the gases running through the manifold, so it can aid turbo response. So getting the gases to the turbine wheel as soon as we can also have its benefits in terms of dissipating the heat as well. That can also be a bit of a benefit. You know, some of the OEM ones where they do run such a large sidewall on the exhaust manifolds, that can, you know, sort of, you know, have effects with heat and stuff like that. So yeah, you know, a nicely designed manifold like this, you know, it's a good option to go to, particularly when we're going to, you know, an aftermarket turbo. We've got all the V-band fittings, we've got external wastegates. It's an ease of, you know, potentially, you know, being able to rotate turbos on the housings and stuff like that, rather than having a fixed location. You know, it's just a bit of, you know, movability there.
And I think you've picked up on a really good point there, being that you've got the V-band housing on the exhaust manifold, and it's a V-band exhaust housing. Rather than the old units that used to be fixed, the T25s, the T3s and 4s, etc., etc., you've got the ability to just put it on, clamp it down. You get a really nice fit because of the ring. You haven't got any of the sealing problems. There's no gaskets involved. There's no bolts that can shear or snap. It's you know, it's a really secure sort of fit and forget solution. And being that you can orientate in any degree to a certain point where your housing obviously will allow, gives you the movement that you require. So when you're coming to fit it and you put in your exhaust downpipes on there, and that, it's just going to make it a lot easier to fit. So you just fit it up, loosen it up, and then tighten it up once it's all fitted. So that's really good. What do you think of the coating? Obviously we've got a bit of ceramic coating on here for a bit of heat management. There's a few options in the UK. Obviously this one was done outside of the UK. What do you think is the advantages of that over having it without it?
So obviously, you know, whenever we're looking to a performance application, you know, we want to be very closely considering engine bay temperatures. So obviously when we haven't got coatings there, we can sometimes find that a lot of the heat radiates out into the engine bay. Once we're radiating out to the engine bay, we can be, you know, reducing intake temperature, increasing intake temperatures, which is obviously going to have a negative effect on, you know, the knock resistance of the density of the air, you know, the overall power output and stuff that, you know, it is going to make. So yeah, obviously a lot of it is to do with, you know, thermal control of, you know, engine bay temperatures. So obviously having the coatings there, there can be twos and fro's between the wraps and, you know, the actual coatings and stuff like that. This generally tends to be sort of a bit of a nicer, bit of a neater solution. Some of the wraps and stuff like that you can find over time as fixings degrade, as the wrap degrades, you know, it can sort of start separating away.
And as you said earlier, you know, with this manifold in particular, you've got some quite small restraints, so wrapping this would be quite difficult. And I have seen, you know, people wrap the whole manifold rather than just individual primaries, but obviously that's not going to be as effective if you start wrapping it as one big package as in individually. And I guess if you wrap the manifold, if you have any issues with the manifold itself, you can't really see anything because it's obviously covered, so there is maybe some disadvantages to wrapping in the case that you can't actually see the particular manifold. But and just explain so everyone knows what this is. That's what part of the manifold is right here.
So obviously on the manifold here, we have got the takeoff port for the wastegate. So our exhaust gases are going to come down the primaries of the manifold into the V-band, and that is going to drive our turbine wheel inside the turbo. So as it turns the turbine wheel, this is what makes the boost pressure on the compressor side. So yeah, that is what we're doing to drive our turbo, getting the exhaust gases into the turbine wheel, you know, to make our boost. So one of the things we want to take into account is we don't always want maximum boost pressure. There may be conditions where, you know, part throttle, low end RPM, if we're trying to do a bit of torque control for a stock engine, we want control over the boost pressure. So what we're going to be doing here is obviously where our wastegate goes onto the side of the manifold here, and we're going to be able to divert the gases away from the primaries out into the exhaust. So what this does, it stops, you know, reduces the speed of the turbine wheel. Which obviously reduces the boost pressure, giving us that control there. And with an output from the ECU and via a boost solenoid, we can control the duty cycle on which, you know, we open this valve at. So if we want X amount of boost, we know we need X amount of wastegate duty. So this can all be controlled in a closed loop feedback from the ECU. So it's a very good, you know, way of getting you know, very good boost control that is properly integrated into the engine management system.
And I think that's the beauty of any type of aftermarket manifold is the size of the wastegate. So if we look at you know, within an OEM unit, you'll find a little penny flap on there, you know, with your actuators very small.
Yeah.
And if you had an outlet that small on something that's going to create a lot more boost like this, you're going to have problems with boost creep, as we've discussed before. So, so having this gives the ability to change the size of the wastegate and basically be able to create that boost control that you've just been telling us about. Just going on to here then, so we've obviously covered the wastegate. We've got the little Turbosmart. We should really mention that it's Turbosmart as well. So both these products are Turbosmart products, really nicely made. I've used Turbosmart, as I'm sure you have, through lots of projects. Very nice bits of kit, and they work very well. This is obviously the blow-off valve. Can you explain what the use of the BOV is?
So obviously with any turbocharged car, we are going to be making boost pressure in the charge side of the engine. When we're in a condition where we're letting off the throttle, we do want to release the charge pressure. So the reason for this is we can actually cause turbo damage. So if we're stalling the compressor through not releasing the charge pressure, this can have, you know, quite a big impact on bearing wear, service life of the turbo. So what we're doing from this is, you know, in a condition where, say, we're letting off the throttle and we want to release the boost pressure, that can be done to, you know, like I said, prevent turbo failure, increase the life expectancy of the turbo.
Which is compressor surge.
Yes.
Such.
Yeah.
So just rolling off the back of that, usually your housing has your surge, anti-surge in there as well, so it's kind of along the same kind of theory. So built into your compressor wheel, compressor housing there, you have your anti-surge housing. These were kind of something that were brought in quite a few years back now. It's nothing new really. But all these kind of benefits are what go into making the control so much better and so much easier when you come into the mapping side of things. So awesome. And what else have we got on the table here? So I guess lastly, we've got this this nice little bit of control here for heat management again. Basically a exhaust housing blanket. Sorry, I had a bit of a mind block there. This goes around the exhaust housing at the back of the turbo. Obviously some heat management. What's the advantages and disadvantages in this bit of kit? Because we have discussed this. So
yeah, so with a product like this, obviously this, you know, this is what we call sort of a physical material, you know, solution, where obviously, say like the exhaust manifold, you know, that is a coating. Now with these material types of, you know, physical coating, physical, you know, thing that we have actually got a barrier from the component against, we do generally tend to find that this does work very well in terms of, you know, the heat not being radiated out as much. And, you know, going to fast, you know, you may have seen some of these videos on YouTube, people have been doing dyno pulls with their hand on the turbine wheel of the turbo, which if you were to do that without it, you know, it would be a not a nice situation. So I would say the only drawback you can sometimes find is with products like this, and this isn't anything against, you know, the specific manufacturer or anything like that. This is more so against the, you know, if we in a situation where we have a turbo line fail, you know, products like this, you know, they can hold the oil inside, which can sometimes obviously, you know, produce a little bit more of a fire hazard, but you know, it's always one of those. There's always going to be a pros and cons to a coating to, you know, a physical thermal, you know, barrier.
I think no matter where you go with something, when you start going into this kind of realm, you're always going to have a positive and negative, and as long as the positive outweighs the negative, it's kind of the risk that's acceptable.
Yeah.
So yeah, just going on to the turbo then, let's just have a quick look at this little beast. So it's a Garret G25 550. These are vastly used through small displacement engines now for sure, and I guess maybe even in some larger displacements in a twin turbo situation.
Yeah.
It's a really nice package. Obviously you've got your V-band centre cartridge here that goes to the exhaust manifold. That's a really nice bit of kit. What other benefits is there to this turbo that you can see on it that could potentially be used if you're in an extreme situation?
So a lot of the one of the things they did introduce with the G series turbos is a lot of the compressor covers do come with speed sensor support. So with that, so where we have our compressor map, say for instance we're on an aftermarket ECU, we can run a speed sensor. So what this will do is help us to keep the turbine in the efficiency islands of the compressor maps. So by monitoring the speed, if we get to a point where, right, well, we're getting past the recommended turbo speed, we are taking that turbo out of its efficiency islands, which will just put, you know, greater, you know, much more heat in there for no gain. You know, you will get to a point where you're just spinning the turbo so fast that all you're doing is just starting to heat set the turbo. So that's a nice little feature that, you know, you do get on there.
And I guess maybe off the back of that, could it be that because you can see the shaft speed, you're also got some safety in there, and that you maybe not overspinning the shaft and having an issue where you may be risking the shaft snapping in half?
Yeah, no, definitely.
It does happen, doesn't it?
Yes,
so.
Yeah, no, obviously it's, you know, as well as a tuning aid, it is also a safety feature. So, you know, if for whatever reason, I don't know, we had a fault with something else and, you know, the turbo does start to overspin, then the ECU can see that, put a safety feature on there, so, you know, we are keeping everything safe and within its parameters.
And I think that's the beauty of running the standalone, which we're going to go into when we get it out, is that you've got the benefits of being able to integrate sensors in there that you can't normally control.
Yes.
And then also not just being able to monitor them, but being able to actually do something about them. You know,
Yeah.
the car will either be able to reduce something, or even, you know, worst case scenario, just shut itself off completely to protect itself. And I think when people start looking at this kind of level of performance, I know it's a big cost. You know, once you start talking standalone, it's a big amount of money, but you've got a big amount of money on this table. So
Yeah.
if you spend it in one area, you should really spend it in an area to control it too. So
Yeah.
no, that's really awesome, mate. It's a really, really good, valuable feedback there for all the components. Is there anything else you'd like to talk about in this section?
Yeah, I think the only thing is maybe just going a little bit further with the, you know, the Garret G series, the reason why they brought them out. You know, a lot of the turbo technology has now, you know, developed massively so over the last few years. With the introduction of the G series, a lot of that was based around, you know, the velocity of the gases, the velocity of the air. So with the G series, we find that you know, our mid-range and our low end, our response times are greater than, you know, what would have been from 10 years ago.
Yeah.
You know, a lot of the technology in the G series now is based around, you know, the spool side of things. Can sometimes find that there can, you know, absolute, you know, say 100% wastegate duty, where, you know, we are using the turbo to its absolute maximum, then we could potentially see, you know, from what we've personally seen on some of the turbo kits, maybe it might not be quite as efficient up top, but, you know, we are talking in a situation about a road car. This isn't a drag car that is going to be used to, you know, maximum RPM, maximum launch and stuff like that. We want to keep, you know, a good response from low end. That is what, you know, we're trying to achieve from here is a road car. And
I think that's quite an important thing to just point out. You know, essentially it's about building the car for what use you're going to have with it. So if you're going to have it as a pure drag car, then you go down a completely different route. I think bouncing off of what you've just said there as well, it's quite important to point out that the exhaust housings on these come with different ratios. So obviously this is an 072 housing. I think you can get these in an 082 or an 086. What's the difference, just so that everyone knows, between the different ratios and what that will actually do to affect the way that the boost is produced with this turbo?
Yeah, so that's, it's a very good question. A lot of misunderstanding there that people might have, that when we're specifying a turbo, it's a very, very crucial part of any sort of build you do on a car. You are effectively setting the characteristics of how the car is going to, how to react to a certain condition. So with our smaller size turbine exhaust housings, we might find that will give us, really good response, mid-range, low end, but we may potentially find when we get up to very high, high-low conditions, there can start to be a restriction there.
Start choking out a little bit.
Yeah, so you start choking out the the performance of the turbo. So then we can go to up to the next size exhaust housing turbo. But obviously, as with anything, we've got pros and cons. The bigger size we go on the exhaust housing, that is going to affect our spool. So
yeah, of course.
For this reason, like we said, a road car, we are basing a lot of this on trying to keep good mid-range and low-end response.
Excellent, excellent. No, it's really good. And I think that we needed to just put that bit in there. So I think that's all I've got on there. If there's anything else you'd like to add to it, then feel free. But for me, that's good.
Yeah, no, I think we're all good on that.
Excellent. Let's lead that into our next phase. Excellent.